Hello viewers, in today's session we are going to discuss another important and conceptual problem from limits. And in this session we are going to discuss this limit, that is limit x tends to 0. And here we have secant pi x square over 2, and the whole power is 1 over x raised to 4, right? So in this class we'll learn how to evaluate this type of limit which belongs to a special class of limits, right? So this limit is of the form that is 1 raised to infinity. So although we have already discussed 2 or 3 problems in our earlier videos, but in this session we are once again solving one more problem related to the special limit of the form 1 raised to infinity. So let us first quickly see the method how to solve these kind of limits. So let us consider the limit, that is limit x tends to a, and consider two functions, say f of x and g of x. And here we have the limit of this form, that is f of x is raised to g of x when x tends to a. And here if the limit x tends to a f of x is equal to 1, and limit x tends to a g of x it tends to infinity or not defined, then this limit is set to attain this form, that is a 1 raised to infinity. So here this problem belongs to this type of limit, that is 1 raised to infinity or not defined. So we'll see how we can solve this limit by using a direct result, right? So we are not going to discuss the whole method, but here we'll directly apply the method to get the value of this limit. So if the value of this limit is suppose taken as L, right? So this L is given by this limit, that is e raised to a limit, and we have x tends to a, and then here we write g of x, and then we multiply g of x with f of x minus 1, right? So what we have done here, we have assumed that the value of this limit as capital L, and this capital L is given by this expression in which we have e raised to limit x tends to a g of x multiplied with f of x minus 1, where e is the famous Euler number, right? And here we have these two conditions, that is limit x tends to a f of x is equal to 1, and the limit x tends to a g of x must tend to infinity. Then if we have these two conditions, then only we can apply this rule. So let us first verify these two conditions for this function, which can be taken as f of x, and this function 1 over x raised to 4, and this function so it may be taken as g of x. So let us take f of x as secant pi x square over 2, and g of x as 1 over x raised to 4, and here the value of a is 0. So let us first find a limit x tends to 0, f of x is secant pi x square over 2. So this limit is equal to 1, because when x tends to 0, then x square tends to 0. So we have secant 0, and secant 0 is equal to 1. And when we take limit x tends to 0, g of x, then we have here g of x is 1 over x raised to 4, and when x tends to 0, 1 over x raised to 4 tends to infinity. So this limit tends to infinity. So these two conditions are fulfilled by f of x and g of x when x tends to 0. So now to get the value of this limit, let us take the value of this limit as L. So L can be obtained by this expression. So we have seen that this limit is 1 and this limit tends to infinity. So the given limit is of this form, 1 raised to infinity. So now the value of the limit L is given by e raised to limit x tends to 0, and g of x is 1 over x raised to 4, and f of x is secant pi x square over 2, and here we have minus 1, right? So now we can simplify this expression. Limit x tends to 0, 1 over x raised to 4, and here we can now write 1 over cos pi x square over 2 minus 1, right? So we can further write limit x tends to 0, 1 over x raised to 4, and here we can now write 1 minus cos pi x square over 2 divided by cos pi x square over 2, right? So taking the LCM here, we have cos pi x square over 2 multiplied with 1. We have 1 minus cos pi x square over 2, and in the denominator cos pi x square over 2. So now let us write L is equal to e raised to limit x tends to 0. We have 1 over x raised to 4, and here we can write cos pi x square over 2, and in the numerator we have 1 minus cos pi x square over 2. So to simplify this numerator, we'll take help of some trigonometry. So we know that cos 2 theta is equal to 1 minus 2 sine square theta. So this is the well-known double angle formula for the cosine function. So we can write 2 sine square theta is equal to 1 minus cos 2 theta. Now replacing theta by theta over 2 to get the half angle formula. So we have 2 sine square theta by 2 is equal to 1 minus cos theta. Now let us replace this theta by pi x square over 2. So we have pi x square over 2. So we have 1 minus cos pi x square over 2 is equal to 2 sine square, and for theta we have pi x square over 2, so we have pi x square over 4. So this 2 is multiplied with this 2, right? So here we have simply 2 sine square pi x square over 4. So now let us rearrange the terms here, and we can take this 2 in front of the limit notation, and here we have limit x tends to 0, and we can take cos pi x square over 2. So here we have 1 over cos pi x square over 2, and then here we can write limit x tends to 0, and we can take x raised to 4 in the denominator of this term, that is sine square pi x square over 4. So here we have sine pi x square over 4, and here we can write x square and we can make the whole square, so that we get sine square pi x square over 4, and x square raised to 2 is equal to x raised to 4, right? And here we have distributed this limit notation with cos pi x square over 2 and this term by the theorems on limits, right? So here we have e raised to 2. Now this limit is equal to 1. So because here we have x tends to 0, so when x tends to 0, this term, that is cos pi x square over 2, it tends to 1 because x is 0, so cos 0 is 1. So we have 1 over 1. And here we have limit x tends to 0. Now let us rearrange the terms here, because now we'll convert this limit into this form, that is limit theta tends to 0 sine theta over theta, and this limit is equal to 1. So now our objective is to convert this expression into this form, that is sine theta over theta. So now we'll write here sine pi x square over 4, and here we have x square. So let us write x square and here pi by 4 and multiply pi x square over 4 by 4 over pi, and here we have the square term. So we have here introduced the factor pi by 4, and to eliminate this pi by 4 we have multiplied this term pi x square over 4 with 4 over pi, so that 4 and 4 get cancelled, pi and pi also get cancelled, right? So now if we take this term, that is pi x square over 4 as theta, we can now write e square. Here we have 2, and then we have limit x tends to 0, and here we have sine theta over theta, and here we have 4 over pi, and this is square. So we can now write e raised to 2 times. Now see, here we can take 4 over pi outside this square term. So we can now write pi square over 16, because this pi goes to the numerator, and we have 4, then we have square, that is pi square over 16, and here we have limit x tends to 0 and sine theta over theta square, and remember theta is equal to pi x square over 4. So now we can write e raised to here 2 times 8 is 16. So we have pi square over 8, and here we have limit x tends to 0, and now we can replace theta by pi x square over 4. So we have sine pi x square over 4, and here also we have pi x square over 4, and here we have the square, right? Now see, when x tends to 0, then pi x square over 4 also tends to 0. So we can now replace this x by pi x square over 4, because this limit, that is theta tends to 0 sine theta over theta is equal to 1. It is valid only when this theta tends to 0, and here we have theta, and here also we have theta. So here we have pi x square over 4, here we have pi x square over 4. So when pi x square over 4 tends to 0, then this limit is equal to 1. So now we can write e raised to pi square over 8 multiplied 1 square, because this limit is equal to 1. So now this expression is e raised to pi square over 8 times 1. 1 square is 1. So this is e raised to pi square over 8. So viewers, the value of this limit L is given by e raised to pi square over 8.